Hello students, welcome to the next lecture on conventional manufacturing processes, and in this lecture we will discuss about different super finishing processes. So first of all, let us understand why these finishing processes are required. Now we know that during the machining operations what happens, we are removing the large amount of material, and due to the removal of the large amount of material the cutting speed is also higher and there are chances of surface being rough, and at the end of the machining processes we are not getting the exact smooth shiny like the surfaces. Now to make the surfaces smoother, shinier and finer, we must need to use the different finishing processes, right? Now there are varieties of finishing processes are also available, but each and every finishing process is not useful for every component. There are certain advantages and disadvantages of also another different finishing processes. So to select the specific finishing processes suitable for a particular component, it is mandatory required to understand the different finishing processes. So there are wide varieties of processes are available, and from that processes we will understand about the different processes that are indicated over here. So these are the different processes, and these are mainly a surface finishing processes: grinding, lapping, honing, buffing, barrel tumbling, burnishing, powder coating and polishing. These all processes we will be understood in detail step by step. So first of all, let us start with the grinding process. Now grinding process, I think we all know what happens in grinding process. One grinding rotary tool is available which is rotating about its axis, and this grinding tool is fed towards the workpiece and it starts rubbing over the surface of the workpiece, and it starts providing a finishing to the surface of the workpiece. But this particular process, we cannot directly consider it as the finishing process, because in this particular case we are also removing the material from the workpiece. So based on the gritty size available of the grinding tool, this particular process can be understood as the cutting process also and finishing process also, because if the abrasive particles attached to the grinding tool are in finer in shape and size, then and then only this will help us to provide the finishing to the particular component. So there are varieties of grinding operations are also available that we will discuss in our particular chapter. So basically this grinding is nothing but the grinding is a rotary tool. This grinding tool will be used to remove the material from the workpiece and to provide the surface finish to the component. So in detailed discussion we will keep it for our further chapter. Now the next process, that is the lapping process. Now what happens in the lapping process, one particular rotary disc is available and this disc is rotating about its periphery. Now suppose if I want to clean a particular component, say if I want to clean the surface, top surface of this particular component, what we will do is we will provide certain abrasives and particle over the surface of this tool or these rotary disc. So we will provide abrasives and the liquid. Combination of these is applied over the surface of this tool, and while this tool is rotating we are pressing our surface which we want to clean over this particular component. So now what happens, when we are pressing towards this tool, it starts rubbing with the surface that we are wanting to clean, right? So as these between these two the cleaning process is taking place, or the machining, or we can say it as the polishing process is taking place. What happens, it gives us the better cleaning or the better surface roughness at the end of the tool. So here as you can see at the point, the bottom tool plate available, it is called as the lap plate because it is used for the lapping purpose. Over the surface of these we are applying the slurry, and the slurry is nothing but the combination of the abrasive and the liquid, and whatever component we need to clean we are moving that component towards this lap plate, and as this plate is rotating this also provides friction to the surface of this workpiece, and it starts providing a better surface or better surface finishing to the component, to the surface that we want to clean. And mainly the important thing that you need to look is this lapping process is performed at the low speed, and it is mainly used to get the tight tolerances, better parallelism, flatness and the better finishing at the end of the surface. So this lapping process involves two type of the action. It mainly involves cutting and the shearing action. And these two is performed by using what? We have now known that we are performing these two action by using the abrasive particles. So this is basically a lapping process by which we are providing the surface finish to the required component. Now, the next one is the honing process. Now, there is a basic difference between this lapping and honing process. Now, we know that this lapping process, we can only perform this lapping process on the external surfaces. We cannot perform the lapping process on the internal surfaces. So, majorly, this honing process is used to provide the surface finish to the internal component. This one is the honing tool. Now, to the internal surfaces, this honing tool is rotating about its periphery, and also this honing tool can be moved in inward and outward direction. That means it can be given the reciprocating motion and the rotary motion. And with the combination of this reciprocating and rotary motion, we are providing the surface finish to the internal side of the component. So the internal cylindrical surfaces can be easily finished using this honing tool. So this is the major advantage of using this honing tool. And this honing tool does what? The honing stones available in this honing tool are held against the workpiece with the controlled light pressure. That's why it gives the friction to the particular surface and provides the surface finish. So this is the major use of the honing process. So the major difference between the lapping and the honing process is what? This lapping process is helpful for the external surfaces, whereas this honing process is useful for the internal surfaces. Now the next one, that is the buffing process. Now you can see over here the buffing tool. Now as you can see, the buffing tool has combination of different parts are attached. So what are these? This buffing wheel is made of linen, cotton, broadcloth or canvas, and it is made by multiple layers of these cloths overlapped on each other, as you can see over here. So this particular tool is used for the purpose of shining of the wood, metal or composite. So we can provide the shining to any of the component by using this buffing tool. And here the material removal is very less, and we are getting the surface finish just by providing the rubbing action or the friction action. Here as you can see, this one we can consider as the super finishing operation, and this helps us for providing the good surface finishing. So this is the buffing tool, and these are the major advantages of buffing process. Now the next process is the barrel tumbling process. Now in our forward processes, what we have discussed that in each and every process we can use a single component. Means at each and every time we can perform the operation on a single component, and after performing the operation on single component, then and then only we can move forward to the another component. Now in the case of the barrel tumbling, this barrel tumbling process is also known as the barrel finishing process, and it is used as a mass metal finishing technique. So this is the most important term that you need to understand. It is a mass metal finishing technique. That means multiple number of components can be finished easily by using this barrel tumbling process. But here the major important thing is the size limitation of the component that we are using. Now it involves what? It involves placing an unfinished metal piece into a horizontal barrel, and then we are adding the cleaning compounds and the finishing media, and then we are rotating. As you can see over here, we are rotating this barrel. Now as we are rotating this barrel, due to the higher rotational speed, what happens? The metals available in it and also the liquids and the surface finishing components that we are added, that got combined with each other due to the rotation. Due to the centrifugal force, it moves outwards to the periphery of the tumble or the barrel that we have used. Now due to the continuous rotating action, what is happening is there is a rubbing action or the friction action between the cleaning media provided and the metal component that are available, and by using this combination we can clean the multiple component or we can finish the multiple component. So this particular method is ideal for the cases where the faster machining or the faster polishing operation is required, or we can say that faster finishing operation is helpful by using this barrel tumbling process. So this process is comparatively faster than the other processes that we have discussed. Now the next process is the burnishing process. Now this burnishing process is one of the advanced finishing process, as this process do not involve the removal of the chip or the formation of the chip, because as you can see over here, one tool rotating about its periphery, and this tool is fed towards the component which surface we need to clean, or which surface we need to finish easily. So to improve the surface finish of the component, what we are doing, we are rotating the workpiece and the tool in the opposite direction, and this tool is pressed towards the workpiece. As this tool is pressed towards the workpiece, what it does, it step by step plastically deform the outer surface of the component, or the unburnished surface. It gets plasticized, and the overall surface of this component gets finished by using this rubbing action and the pressing action. Now as you can see over here, this burnishing operation is the process of getting a smooth and shiny surface by contact and rubbing of the surface against the walls of the hard tools, and it is mainly a finishing and strengthening process. It can be done using a sliding surface when the local contact stress exceeds the yield strength of the material, because we know that, as in the stress strain diagram we also know, when the elastic limit of the component increases, when we are applying the force higher than the elastic limit of the component, then and then only plastic transformation takes place. So over here the force required, or this pressing force is required, it needs to be higher than the yield stress of the particular component. And the basic requirement is what? The foremost requirement is this tool needs to be harder than our work piece, because if this tool is not harder, then there might be a chances that this workpiece will provide the scratches over the tool, and we cannot get our basic output that we require. That means we cannot get the desired surface finish using this process. So this burnishing process is advanced finishing process due to the main reason, that is, it do not involve the removal of the material, but it plastically deforms the material and provides the cleaned surface over the workpiece that we want to finish. So this is all about the burnishing process. Now the next process is the powder coating process. Now the powder coating process is different than all the processes that we have discussed, because in all the discussed processes what we are doing, we are slightly removing material from the surface of the workpiece, or we are just plastically deforming the material from the workpiece. But over here in this particular case, what we are doing, in this case we are applying a dry powder that is fused on the surface of the workpiece, and then when it is cured, it provides a smooth coating on the surface, and it provides the good surface finish compared to the other processes. That means there are two objectives that can be achieved easily by using these powder coating processes. The first foremost objective is what? By applying the coating, we can use the coating such as it provides the better surface finish also, and it also provides the oxidation resistance. Second, if we use the proper powder coating material, then we can also provide the toughness to the outer surface of the component by using this powder coating technique. So basically it is a finishing process in which dry free flowing thermoplastic or thermoset powder material is applied to a surface, then it is melted over here, and when we are giving a time it to cure, it harden into the surface of the particular component, and it provides the better surface finish. This process is suitable for varieties of material, not only metals, it includes metals, plastics, glass, and provides both. It is useful for both functional and decorative purpose also. So based on the requirement, this powder coating techniques can be used. Now the last process is the polishing process. Now this polishing process, we have heard this name many of the times. We are many of the times doing the polishing. So what is this term polishing indicates? So this polishing is nothing but the process which removes the scratches, tool marks, pits, or other defects that are generated due to the cutting action. So these polishing involves are made of the leather, or maybe a wool or maybe a canvas having the abrasive grains set up with the glues or the thermosetting resins on the wheel. Here the workpiece is held against the wheel and then it is rotated by 50 meters per second approximately at this speed, and the polishing process is performed. Now this polishing can be done manually also, and it can be done by using the machine also. Now this polishing process, there is another one important term is involved, that is we can use the endless belt machine also, which is coated with the abrasive wheel to perform the polishing operation. But majorly you need to understand that it is not used for dimension correction, but sometimes it can be used to maintain the tolerances. Means to maintain the tolerances, this polishing process is helpful, but to maintain the dimensional accuracy, this process is not used. Mainly the abrasive particles available in these polishing operations on the tool, that are the alumina or and the diamond, but in most of the cases alumina is used as the abrasive material to provide the polishing process. So it involves majorly a two-step. The first, by using the abrasive materials, what it does, it removes the fine amount of material from the surface, and then due to the continuous friction and the rubbing action, it provides the continuous frictional heating, and due to which we are getting the polishing on the particular component. So this is basically a simple discussion about the polishing process. So now I hope you have the clarity about all the different processing surface finishing processing involved during this entire lecture discussion. So each and every surface finishing process have their own advantages and disadvantages. Such as if we want to finish the external surface of the component, in that case is what which process will be useful? In that case, the lapping process will be useful. But if we want to clean the internal surfaces, at that time the honing process will be useful. Similarly, if we want to clean the multiple component at a time and the sizes of that component are comparatively smaller, at that time the barrel tumbling process is also useful. So that means each and every process have their own advantages and disadvantages. So we must need to take care that at which particular time which surface finish process needs to be used. So this is overall a basic discussion about the surface finishing processes. So I hope you got the clarity about the different processes involved during the surface finishing processes. So looking forward to see you all in our next lecture. Up to then, thank you.